here in this particular slide, we have and we will get an idea of shortest path algorithms now using the Dijkstra algorithms. Okay. Now, earlier in the TPS activity, we have discussed about the Dijkstra algorithm, and here on the basis of the idea of Dijkstra algorithm, we have share one problem in this particular slide. Now the problem is find the least cost shortest path, least cost shortest path from a given source to all the nodes for the following network topology with given link cost. So this is the particular graph where the graph considers as the u, v, and u is the starting and v is the destination, with a having a each h is having a cost, and that is called the cost path of this network topology. Here given is c of x comma y, that is the link cost from node x to y, infinity if x and y are not direct neighbor, and the c is that is predecessor node along path from source to b. Now next we are going to solve the problem. Now what here we will do is that we have to apply the iterative algorithm. That is, first is the iterative algorithm. After k iteration, we have to know the least cost path to k nodes. That is, k may be 1 to n, and s is the nodes whose least cost path definitely known. That is, initially s is equal to, here in the graph is u. If you think the earlier slide, and u is a source node and one node to s in each iterations, and d of v is the current path from source to u to node v. That is, initially d of v equal to c of u comma v for all nodes v adjacent to u, and d of v is equal to infinity for all nodes v, and continually update d of v on shorter path are learned. Now here this is the particular algorithm steps of Dijkstra algorithm which is applied in this particular problem. Here initialization is s equal to u for all nodes of v. If v is adjacent to u, then what will happen? D of v, we can find out d of v is equal to c of u comma v, else d of v equal to infinity. Next then it will go to the loop. Then we find w which not in s with the smallest d of w, and we have to add w to s, and then we are updating d of v for all v adjacent to w and not in s. So d of v, the minimum, that is equal to, we have to find the least cost, right? So we have to apply the minimum that is path or minimum mean value of the total entire path. So d of v equal to mean of d of v, that is source vertex, comma d of w plus c of w comma v. D of w is the destination, this is the weight, and c of wv is the, that is edge weight. And we have to go to, this loop will go on continue until all nodes in S. So this will go, the loop is running, so there is a line from here to that is from here to S, because the loop is going to continue till all the nodes are visited. Now we are go to the graph. The main graph is from the starting is the, this is the u, right? This is u. So from u we are considering u to this node is 3, and here is 2. So 3 is less than 2. We will take so 2 is 2. We will take this 2. So because here we say that 2 is less than 3. So here we are seeing that 2 is less than 3. So we are taking this particular line. So the this is the u starting node. You are going to this particular node. Here we are seeing, we will see that the edge weight is 1 and edge weight is 4. So which one is less? The 1 is less. So we will consider this. So if you are considering 1 as a less, so we are taking what? That is, we are taking the 1 here. So if you are taking 1, so from we will go to this particular node. here we are seeing we are going this side and this side also. So here 4 and 5, 4 is less than 5. So we will consider this particular first. 4 is there, so here we are considering 3 to 2, 2 to 5, 5 from here we are going, 3 to 2 is we are going to here this particular 2 because 2 is less. So in this way we are considering we are traversing from here from 4 we are traversing to 1 because this is the only one options we are getting from 1. So we are traveling 3, 2 and 1. Right. Now next we are considering that 3, 2, 1. So from this is the starting node U. So from here 2, then 2, after that 1, then again it is 5. So now up to 2, 1, 5 we are seeing that this is the particular node U, that is from 2 to the edge 2 we are considering because this is much less initially we have seen, then it is a 4. So we are finding that this is the shortest path which we can find out this. So shortest path 3 will be what? This is from U. Shortest path 3 from U is this 2. Then we are going to 1 or 4 we can take if we say, and then from 1 we are getting the 5 because 5 we can move from this 5, and here from V vertex, from this V vertex we are seeing 2 and 1. So we are considering 1, and from Y there is only one path from Y to Z, that is equal to 1. So from V the link will be U comma V. From W it is U comma W because this is U comma W, and from X we are getting U comma W, Y also U comma V, Z U comma V is S U comma W, and T is U comma W. This is the shortest path 3 from the graph. Now if we analyze the graph, we are seeing first is graph operation. The method incident edges is called ones for each vertex. The label operation, we set or get the distance and locator level of vertex Z big O of degree Z times. Setting getting our level takes big O of 1 time. And priority queue operation, each vertex is inserted once into and remove once from the priority queue, where each insertion or removal takes big O of log n time. The key of a vertex is the priority queue. It's modified at most degree W, and the complexity is big O of log n. Dijkstra algorithm runs at big O of n log m, log n times provided the graph is represented in the adjacency structure, and the running time can also be expressed big O of m log n since the graph is connected. That's the end.